Hello, I am making this video in replacement of the lecture that we were supposed to have today, Wednesday. There are no classes at Emmanuel College because it's snowing and, well, it is cold. And some other issues, I guess. But for me and for you, there is something that you have to learn. Class suspension does not mean learning suspension. Okay? So you are supposed to watch this lecture and you are supposed to participate in the discussion that is not going to be finishing today. You are going to have time to post until tomorrow at the end of the day. And it is going to be about viruses. So we're done with chapter 26 on the topic of the origin of life. All these topics that we haven't covered, those are the ones that are going to be addressed. And something else, something quite important before coming to this chapter. Here, you have in the announcements one specific topic that is in the beginning, how was life? Look, the announcements, what they are supposed to give you is not just specific information. Oh, there's no classes, bring your book, please study. No. For me, it's something more. When you participate in the discussion, what I do is I collect the main topics that you are addressing, and also what I do is I try to respond to your questions. And that is what you should read, because I'm going to give you a tip for my exams. I start looking for questions in my exams in these announcements first, and then the book, the PowerPoint, the classes present. Let's recall this last announcement. So I start with saying about the conditions that have to be in this planet so that life could begin. I'm giving you here a little video about that. Then I'm coming about the topic of historic geology. And some of the critics that says that, well, historical science is not the same as practical science. That's not the point. Then about what somebody mentioned, that it is possible to calculate the age of the earth based on the Bible. I give my opinion in this paragraph. Then, well, some other specific questions. And by the way, here I am making the same announcement for all the classes that I'm teaching. So maybe you're going to see something that is maybe totally unrelated to whatever all your classmates have been posting in your specific course, in your specific sections, I mean. So here's, for example, what about ice ages? What about the Hadean, Eon, and things like that. Then something about some of the questions that you make. It was about, could life come from outer space? I have a paragraph about that. Then what is how the atmosphere changed and what was the consequences of that, how life was originated. Somebody asked which was the first species. Here I have something about that. And there was questions. There were some questions about glaciations, plants, plate tectonics, the future of the Earth, and how the climate changed. And also there was something else about endosymbiotic theory that I was not able to address, but it is on the book, and it is important. We're going to also recall that when we're going to talk about bacteria. So this is something that you are supposed to read at least before the exam. Got it? Cool. Okay. Let's go now with chapter 27. So what you have here is the topic of viruses and what viruses do. Let's check this. If my computer is going to charge properly, and hopefully YouTube is not going to oh yes. They want us to make these announcements, no? These announcements with their propaganda. Yeah, nothing we can do, just to wait for a moment until this announcement is finished. And then, yeah, here is what I want you to see. This is a specific movie that deals with this topic on viruses. What happened here is...
You had a seizure this morning, Beth. No.
See?
As of last night, there were 32 cases. Unfortunately, she did die. Right. So, can I go talk to her? Mr. Amos, your wife is dead.
What
What are you talking about? What happened to her?
I will freak out too.
What happened to her?
Virus.
Is there any way someone could weaponize the bird flu? Is how we're looking at it. Someone doesn't have to weaponize the bird flu. The birds are doing that.
There's a
Watch this. It's transmission. We just need to know which direction.
On day one, there were 2 people, and then 4, and then 16. In 3 months, it's 1 billion. That's where we're heading. They're calling out the National Guard. They're moving the president underground. People will panic. Get away! It will tip over. The truth is being kept from the world.
Cook your samples, destroy everything. Hello. I need you to get me the names of everyone who serviced this room. It's an emergency.
You can't panic now.
I know.
I'm going to get you home. I got people too, Dr. Cheever. We all do.
Don't talk to anyone. Don't touch anyone. Stay away from other people.
They're going to die. We're not sick.
It's figuring us out faster than we're figuring it out. It's new, Tracy.
Whoop. Well, what was this about? This was about what terrible viruses can do. And of course, that was a movie, but science fiction, not really. Yeah, Resident Evil and all the zombie movies, those are science fiction, but this is something that could happen and that have happened in the past. Humanity was in these conditions with some of the most terrible viruses that you can imagine, killing people like flies, like insecticide kill flies. So viruses are important things to consider. However, not all of them are pretty bad. We need to learn about them. So what are viruses? You made a quiz, didn't you? Sorry if you didn't, you have a 0. That is how it is. A virus is a nucleic acid core surrounded by protein. That it is. Is it a cell? No, it's not. It doesn't have cytoplasm. That is what defines really a cell. And this nucleic acid could be DNA or RNA. Then this nucleic acid could be circular or linear and could be single or double strand. The RNA viruses may be segmented or not. So the viruses, some of them have been classified by genome. That means that the people that studies virus have determined which one are their genes. And we have RNA viruses, DNA viruses, or retroviruses. So there are different shapes of viruses. Some of them have this helical capsid. This is one of the viruses that are quite common in the plants. Some of these viruses kill a lot of plants, like the virus of the tobacco. Tobacco has been a very, very important plant for industry for the rising of the United States, and especially in the South. Well, when there are these plagues, the productions get down and could kill a lot of plants. So if you're an agricultural business major, this is something that you should consider. The adenovirus is one virus of the cold that have this specific capsid. So this is the DNA here, and what is outside is the capsid of protein. Another one that is a bit more complex, that it's quite similar to spaceship, a little spacecraft, is here the bacterial virus that are also known as bacteriophage. So that has an icosahedral head and an helical tail. To have these little legs that are used to attach to a bacteria and to inject the DNA inside the bacteria. And we have this virus that have an helical capsid within an envelope. So this is a bit more complicated virus that has an RNA, has a capsid here, and then has an envelope. And here some specific proteins that are recognized as antigens. This is the virus of the influenza. So, is this what you have in your head when somebody mentioned virus? Well, or virus of the computer? Yeah, as you have seen in that that movie, well, that is more realistic than the movies of Resident Evil. But what is the main point? The main point is, well, somebody is working in a sort of secret research, then something got terribly wrong, and this virus start to get into people, and they make people zombies. And what do zombies do? They go and try to make more zombies by killing people. And the people that are not really dead, they are sort of undead, they are the walking dead or whatever, and they start to propagate that. Okay, what is right and what is wrong in these sort of movies? Well, something that is right is that the viruses are parasites. Are there some viruses that are not parasites? We don't know any case. All viruses need cell function. So they have to be parasites. Yeah. Then they have to infect specific hosts. We have viruses just for us. There are some viruses that are just for the dogs. They are going only to infect dogs and not us. So each type of virus has a limited host range. And there is also this characteristic, the tissue tropism. What is the meaning of that? That inside the host, this virus is only to affect specific tissues. For example, the virus of hepatitis. Hepatitis is going to affect only your liver. It's not going to affect your lung or your heart or anything else. By the way, let's imagine that, yeah, it's true, that there is a sort of virus that make people zombies. What is the point? Everybody will be a zombie when the zombie just overtake the earth, and then what? Everybody's dead. That's nonsense. A virus goes to a specific animal, person, or plant, and the idea is to disseminate. By the way, something that is true is that there are some sort of viruses that make people like zombies in terms that they affect the nervous system, and people start to do quite crazy things. They became quite crazy. Well, of course, this is a picture from the computer. No, I mean something that you play video games, so of course kill it, no problem. Okay, but let's become a bit more serious. Do you want to see a real zombie? This is one. I found out this in a creeping web page when they're posting historical photos. That was the last person that died with rabies in the United States in a hospital. That's the information that I have. Oh yeah, people die with rabies maybe everywhere, but here in the US at least, when the guy was in a so advanced stage, he couldn't control himself. That was he was restrained and all. He died. He stayed like that until he died. He was having terrible hallucinations. He was attacking anybody else who was close to him until it was impossible to do anything for him. So yeah, those people like this, those are their terrible zombies. Then, how is the nature of these creeping critters that are the viruses? They have to replicate. And how do they work? They work in a very, very similar way as the virus that you can cache in your computer. A virus have a specific set of instructions. With this set of instructions, what do? They hijacked, in this case, your computer. In the case of a living being, it hijacks the cell machinery. Then what a virus does is replicate. That is exactly also what the viruses do. They replicate and they do damage. They just make everything crazy. And they need a host. They cannot do anything if they don't have a host. Well, something else that goes on here with your book is about the shape and size of viruses. Here you have this picture in your book. When there is, it is quite useful because it's giving you comparisons. This is the part of the shape of an eukaryote cell, that is the yeast cell. Here is a bacterium that is very, very common, Escherichia coli. This is another bacterium that causes a lot of infections, maybe usually throat infections, that is Streptococcus. And here you have all this variety of viruses. And got the comparison with a protein. Some very small, some quite big. Then let's go on with how is the instruction, this set of instruction that these viruses have. It is like, well, the hackers that are going to get into your computer. So they vary greatly, and those set of instructors are in the genome. The genome are the collection of genes that is that are in the nucleic acids. Then, mostly the RNA viruses are single-stranded, and we have DNA viruses that most of them are double-stranded. Single-stranded, that means one thread of the chain of the nucleic acid. Double-stranded, well, the double thread that goes there. But here, the RNA viruses, they are divided in this way. The positive strand virus is a viral RNA that serves as a messenger RNA. Messenger RNA by one. That's what this is Bio 2, because you're supposed to know the basic of Bio 1. Hmm? Remember your nucleic acid class, the genes, what is the sort of replication of the cell, how the proteins are being made. You need messenger RNA. Then, the negative strand virus is a genome that is complementary to the viral mRNA, the messenger RNA that the cell has, the eukaryote cell has. And retroviruses, like the HIV, they employ a specific enzyme. And this enzyme's name is the reverse transcriptase. They reverse the viral RNA into DNA. So we have another group of viruses that are the ones that kill, destroy the bacteria. Yeah, this is a representation of a specific virus, and this is the poor bacteria. So why they call it bacteriophagus or phagus? This means that those are the one that eats the bacteria. And in biotechnology, they are being widely used. So they do that. They infect bacteria. And they are quite diverse. And the one that is the most common one is the specific T virus that infects E. coli. It is not the T virus of that Mila Djokovic is trying to destroy. This is quite different. This T virus attacks the bacteria. And the E. coli is the bacteria that is the most common bacteria that we all have them, this bacteria in our guts. But there are some strains that causes terrible diseases. So look, this picture in your book is very, very important, and you have to learn it and understand it. Because this specific bacteriophages have cycles. And this is a specific case of the fake lambda. Fake lambda has been studied a lot, and as I said, it's been used in biotechnology now. Now scientists know that these virus have two cycles, the lytic cycle and the lysogenic cycle. So the lytic cycle is what you already have seen in the previous slide. Here, the phage is attached to the bacteria here, and it starts to replicate. Well, first of all, it penetrates the viral DNA, is infected here. Then here, the cell, the bacteria cell, start to produce the protein and nucleic acid of this virus parasite. Then it's going to assemble new viruses, and new viruses come out and destroy the cells. So in the lytic cycle, it's just a cycle of destruction. They got into the bacteria and they start to replicate, and the bacteria is destroyed. That's it, the lytic cycle. But sometimes this virus does not destroy the bacteria in the moment. This virus harnesses the bacteria. Yes, it dominates the bacteria. And we call that the lysogenic cycle. So here in the lysogenic cycle, well, something that is common is, well, the virus has to penetrate here and the bacteria, but here the genome of the virus gets integrated in the bacteria. And here the bacteria start to replicate and nothing happens. The virus is here. And there is something that is going to happen, a specific situation where this bacteria is going to enter here, the lytic cycle. then all the rest of the components, the capsid and all that, is going to be assembled, and the bacteria enters the little cycle and is destroyed and killed. Not after a lot of bacteria now have this virus. So it will be really more boring to make a movie about killing bacteria than to kill people. No? So this could be like zombie bacteria. Something else that happened in this lysogen cycle is this specific phenomenon that is called that phage conversion. How that happened to you? You're walking to the street and then somebody says, hey, I have something that is going to boost your athletic skills. Take these pills. Take this. And this caricature wants to tell you something like that, no? They're supposed to be two bacteria. And this guy said, hey, you want to be a superbug? Stick this into your genome. Even penicillin, that is an antibiotic, will not be able to harm you. So what's the point here? The point here is that sometimes the viral genes that got attached to a bacteria is not going to kill them in the moment. They are going to make them more powerful. So the viral genes may be expressed there after the bacteria has been called these genes. So the phenotype of characteristics can be altered by the prophase. This is the prophase. So something may happen to this bacteria. And that is the case of the bacteria of this terrible disease that kills a lot of people, mainly in poor countries, cholera. Cholera is caused by a bacteria. Then it's known as fever cholera. But the original bacteria is harmless, doesn't do anything. However, there is a virus that enters there and is going to make that. It's going to make a deadly bacteria. It's going to make zombie that's going to kill. That's it. Okay? That is what I wanted to share with you on this topic. And we're going to go on for the next class, with HIV. Please read about this, HIV, and the other sort of diseases that are caused by virus. And the last chapter about prions, we're not going to make it. Okay? See you then. Keep warm. Have a nice time.